Good afternoon, everybody. Welcome. My name is Scott Morrison. I am a Senior Networking Solutions Architect, and thank you for joining us today for NIS302. We'll be talking about network inspection design patterns that scale. We'll be really getting into some really cool architectures. We'll also talk about a really cool customer case study where we're pushing 10 terabits per second and hundreds of billions of daily connections through AWS Network Firewall. So stick around, join us, and we'll have a nice journey here today talking through some great ways to scale your network inspection architecture. With that, I'm going to hand it over to my colleague here, Pratik, to introduce himself and take it away.
Thanks, Scott. My name is Pratik Mankad. I'm also a solutions architect at AWS, specializing in networking. Hope everybody's able to listen loud and clear. Perfect. So, before we begin, any cricket fans in the house? Nice. Yeah, we had an awesome game on Sunday. Really enjoyed it. So I had to bring that up. Sorry about that. But yeah, let's begin. So here's the agenda for today's session. We are going to go over various inspection services, briefly introduce them. Then we'll talk about various inspection design patterns, followed by the AWS Network Firewall case study that Scott just talked about, and then we'll conclude with orchestration and observability. So security, when you're dealing with security, it should be a layered approach. And what I mean by layered approach is like we have a bunch of AWS services that are available for you to use. So you should be using that as a layered approach to achieve your security goals. And with that, the first layer that comes to you is the VPC. Basically, you want to protect your resources inside the VPC, and that's where you can rely on things like security groups, network access control list, and whatnot. Then comes the boundary of the VPC. So VPC boundary, you want to inspect the traffic, inspect and protect the traffic that is going in and out of your VPC boundary. That's where you can start utilizing constructs like AWS Network Firewall. You can use Amazon Route 53 Resolver, DNS Firewall, and whatnot. So that's where it basically allows you to inspect and protect the traffic at the boundary of the VPC. And then you might want to protect the application itself, and that's where you can start utilizing AWS Web Application Firewall. So basically, again, so as you can see, this is like we made like a layered approach of the services within the VPC, at the boundary of the VPC, then protecting the application itself. And then when you're using this lot of services, then the other thing that comes to mind is like, I want to also observe the network traffic. And that's where you can start using services like Amazon VPC flow logs, AWS Transit Gateway flow logs, Amazon VPC traffic mirroring that allows you to get the visibility into the traffic flows that is going into your network and outside of your network. And last but not the least, you want to use a service like AWS Firewall Manager to orchestrate all these various constructs that we just talked about in order to achieve your security goals. So with that in mind, let's take a look at these services at a more closer look and see how they perform. So at that point, let's begin with the security groups. So security groups, as you all know, I'm not going to spend too much of time on this thing, but it's a stateful firewall, simple stateful firewall that allows you to inspect and protect traffic that is flowing into your resources. So as shown in this slide, you have a security group associated with an EC2 instance or an application load balancer or a network load balancer. It basically It's stateful in nature. It allows you to configure, you can configure allow rules. If you don't configure any allow rules, absence of allow rules means implicit deny. And it also allows you to cross-reference. So basically, as again seen on this slide, you have you can reference a security group that is associated with an elastic load balancer in a security group that is associated with an EC2 instance, thus enabling security posture that allows you to just ingress the traffic from an ALB. So you can do a cross referencing. It works for VPC peering within the same region as well. And basically, as I said, it supports. It doesn't support any deny rules, so it's only allow. And in the absence of any allow rule, it's an implicit deny. The next one is network access control list. These are basically stateless firewalls, and what it means by stateless is like you need to configure rules in both the direction, inbound and outbound. And they are associated. It allows you to inspect and protect traffic going in and out of your subnet. So it allows you to protect the traffic going in and out of a subnet that it's associated with. And by default, again, it's you can configure allow and deny rules, and by default it comes with a deny rule. So in the absence of if the packet doesn't match any of the numbered rules, then it will match this default deny rule, and traffic will be dropped. And this rule cannot be modified or removed. So often we run into a situation where we have customers come and talk to us as like, okay, this is good, but we want to go beyond the security groups, and like, what are the reasons for us to go beyond security groups and network access control lists? So with that in mind, like one of the main reason might be scale. So if you're looking at security group, by default you can do 60 rules per security groups, and up to maximum of 1,000 rules. You can, and when it comes to NACLs, you can do 40 rules by default, 20 rules by default, going up to maximum of 40. So if you have a use case where you want to go beyond this quota, then you have to start exploring constructs like additional security constructs like AWS Network Firewall. The other one might be the inspection depth. So if you look at security groups, network access control lists, they both operate at network and transport layer of an OSI model. So it basically allows you to implement rules with IP address port protocols, but it doesn't have an ability to configure rules based on the application parameter. So if you want to, if your use case requires you to do application level rule configuration, or you want to do protocol detection or FQDN filtering, that's where you start again utilizing constructs like network firewall, Amazon Route 53 DNS firewall, or web application firewall. And last but not the least, management might be a point of consideration where you want to simplify the overall management story by basically creating a centralized infrastructure architecture and whatnot. That being said, Scott is going to talk about Firewall Manager service in depth, but it's an orchestration service that allows you to configure and audit things like security groups, network firewall rules, DNS firewall, and whatnot. And in the April of this year, we also added the support for configuring and auditing network access control list. So we looked at security groups, NACLs, reasons to go beyond security groups and NACLs. Let's take a look at Route 53 Resolver DNS firewall. So basically, it's a DNS firewall for Route 53 resolver and resolver endpoints. It allows you to easily allow and deny outbound DNS traffic that is originating from your VPC. It's a highly managed and available service, and you can either create your own custom domain list, or you can use the AWS managed list to either allow or block a particular domain. It allows you to configure custom deny actions, and also integrates nicely with AWS Firewall Manager service. And again, earlier this year, in April, we launched Route 53 profile. It's a new offering that allows you to configure DNS-specific Route 53 configuration, including DNS firewall. So you can basically use that to configure DNS firewall across multiple VPCs, across multiple accounts. And we'll talk about the next one is the gateway load balancer. This is an important construct when you start playing with network firewall. So gateway load balancer, it's a type of load balancer under elastic load balancing family. It makes it easy to deploy, scale, and manage network virtual appliances. And the way it works is its traffic is routed to the gateway load balancer through a construct called gateway load balancer endpoint. So if you've played with interface endpoint and whatnot, AWS Private Link, it's built using the similar technology. So it's basically a transparent construct, which is a combination of a gateway in the front, network gateway. It acts as a network gateway in the front, and as a layer 4 load balancer on the back end. So it allows, because it's a transparent construct, the original traffic stays unmodified. It doesn't get modified, and the firewall is able to take a look at the original traffic. And if you compare it with application load balancer or a network load balancer, those are all reverse proxies, versus this is again a transparent construct. So traffic is routed through this construct, versus in the reverse proxies, the traffics are getting routed to those load balancers. And because it's also acting as a load balancer in the back end, you are able to use it provides horizontal scaling to the appliances, fault tolerance and whatnot. And you can offer it firewall as a service. And we'll see how that matters when we talk about network firewall in a minute. But gateway load balancer endpoint that routes traffic to the gateway load balancer, those are zonal in nature. And what I mean by that is a traffic that is entering a gateway load balancer endpoint in an AZ, in an availability zone, will always route the traffic to a node behind a gateway load balancer in the same AZ. So that's an important thing to keep in mind when you're architecting your inspection architectures, which are based on gateway load balancer. So why I brought up gateway load balancer? Because AWS Network Firewall is built using AWS gateway load balancer. And so network firewall, it's basically our managed offerings that allows you to deploy essential network protections for your Amazon VPC. It's a managed service that scales automatically with your network traffic, so you don't have to worry about deploying and managing infrastructure. It can basically intercept the traffic coming in from transit gateway, cloud WAN, direct connect gateway, site-to-site VPN, virtual private gateway, internet gateway, and whatnot. It integrates nicely with the AWS Firewall Manager, so you can use AWS Firewall Manager to centrally configure network firewall rules. And then when it comes to logging, it is able to send the logs to destinations like Amazon S3, CloudWatch logs, Kinesis, or you can even use partner-offered solutions to audit the logs that are available to you. And it can also you can also insert, we'll take a look at it when we look at the design patterns, but you can also insert the network firewall between the subnets, so resources between the two subnets. So you can insert the firewall and inspect the traffic between the subnet as well. So before we take a look at the other service, it is important to understand, because gateway load balancer, we made it available for our partners as well. So you will see a lot of partner firewalls that are also built using gateway load balancer. So there is a difference that you need to understand when it comes to AWS Network Firewall and a third-party firewall. So as shown in this diagram, basically what happens when you're using a third-party firewall, you end up creating what you call as inspection VPC. In that, you'll have your gateway load balancers, and then gateway load balancers will have your third-party firewalls running as a node, and you'll add them as a target behind a gateway load balancer. And then in the inspection VPC, where you want to inspect the traffic, you will end up creating gateway load balancer endpoint, which then routes traffic to the gateway load balancer and the firewall behind it. So in this situation, the inspection VPC, the gateway load balancer, the firewall fleet, it's all customers' responsibility. They are responsible to manage the infrastructure, to scale the infrastructure as per their traffic needs. When it comes to network firewall, everything on the left-hand side, the spoke VPC where you want to inspect the traffic remains the same. It's the inspection VPC that we take over. Basically, we now own and operate the entire inspection VPC for you. So it's again operating along the principles of shared security model, where we manage the underlying infrastructure for you, so you don't need to worry about scaling the infrastructure up and down to meet your traffic requirements. That being said, as a customer, you are still responsible for configuring the AWS Network Firewall. So that's basically, if you look at it, the third-party firewalls, meaning they are also offering firewall as a service. That being said, when you're running it, you are responsible for those things. When you're using network firewall, we take care of the entire infrastructure for you. And last but not the least is the Web Application Firewall. Web Application Firewall, as the name suggests, we can use it to protect your HTTP and HTTPS requests that are forwarded to your protected web application resources. So that's where Web Application Firewall comes handy. We'll talk about it, when to use this and Network Firewall in a minute. But basically, these are the services that I wanted to go over at a glance. So this slide is basically about that. It summarizes all these services at a glance. And the key takeaway here is basically you need to, again, going back to, you need to make a use of the layered approach of all these services to achieve your, to be a part of your defense in depth strategy to achieve your security goal. So versus picking and choosing a service. So that's the purpose of this slide, basically creating a layered approach. And you can basically integrate services together to achieve your security goal. So with that, let's start taking a look at the design patterns and how you can insert the services, basically network firewall, to inspect and protect your network traffic. So security, again, is job zero for AWS and also for the customers across the board. And many times the discussions begin at the network layer, and even though it might not be the only place, but it starts with that because it requires a lot of attention, and rightfully so. And organizations are deploying next generation firewalls, intrusion prevention and detection systems, and as they are moving to the cloud, their environments are changing. Their environments are becoming more dynamic, and all of us are looking for patterns, they're looking for security postures to mimic what they already have and to start using the similar security posture. So while discussing with our customers, we are seeing unique traffic inspection flows that are emerging, right? So if you look at it, the first one being they want to inspect the traffic for the resources that are running inside the VPC, within the VPC. They want to inspect the traffic between the resources within the VPC, across the VPC, but in the same region. They want to inspect the traffic between the resources in multiple VPCs, but at this point they're like spread across the region. Then we have a number of use cases where they want to inspect the traffic between the VPC and their on-premises infrastructure, hybrid environment. And last but not the least, they want to start looking at internet egress and internet ingress, where you want to inspect the traffic going out to the internet or traffic coming in from the internet. So these are the inspection flows that are emerging, and they want to kind of start inserting the security construct in these flows. So before we start taking a look at various design patterns that are applicable to this inspection flows, it is important to understand the firewall deployment models, network firewall deployment models. So these services are out there for quite some time. If you have worked with any of the AWS resource, you have come across the word as a distributed deployment model, centralized deployment model, and you must be thinking, what are those things? So basically, firewall deployment model is nothing but placing your firewall and aka your firewall endpoints. So in this situation, the first one is the distributed deployment model, where each VPC is having its own stack of firewall, and it's basically distributed across multiple VPCs. This is a common use case for ingress inspection architectures. Even for egress, it can be a common use case where you have an isolated VPC, edge VPC, where you want to basically focus on those kind of things. So it comes pretty handy over there. The next one is the centralized deployment model. So as you can see on the slide, in centralized deployment model, there's a centralized inspection VPC which is hosting your firewalls, and all the traffic from your spoke VPC is routed to these firewalls through a construct like Transit Gateway or an AWS Cloud WAN. So basically centralizing everything and sending it to a network firewall. And we recommend this model for east-west traffic inspection, so VPC to VPC, between the region, within the region, or VPC to on-premises. So this is a recommended model for those kind of traffic inspection patterns. And then we have also seen customer going for a combined deployment model where they're making use of best of both the worlds. So it's like distributed for an edge application versus centralized for even egress and east-west. So with that, let's get started with the design patterns. The first one is, as we saw on the slide, intra-VPC. You want to inspect the traffic between the resources, between two subnets. Or you end up doing, you create a gateway load balancer endpoint, add that as a target in your VPC route table, and traffic gets routed to the firewall for inspection before it goes to the destination. This is a simple case of a single AZ, so perfectly fine. If we go back to my previous statement about the load balancer being a zonal endpoint, it becomes interesting when it becomes multi-AZ scenario. And in case of multi-AZ scenario, you need to be mindful. You want to pick an endpoint for inspection between the two AZ. And the reason behind that is like firewalls are stateful in nature, so you don't want initiating traffic going to firewall 1 in AZ1 and return traffic going to firewall 2 in AZ2 and basically introduce an asymmetric routing. So in this situation, what we have done is for AZ1 and AZ2, we picked a firewall node in AZ1 to inspect the traffic. We did for AZ2 and AZ3, we picked AZ2. For AZ1 and AZ3, we picked AZ3. What this allows you to do that is like it's reducing, like it's compartmentalizing it. So if for some reason AZ gets affected, then only the traffic flow between that AZ is impaired, but the others keep working fine. So that's where this thing comes handy, and that's where the zonalness of gateway load balancer endpoint becomes an important aspect to be keeping in mind. So with that, let's move on to inspecting traffic between the VPC, but within the same region. So as you recall, I just mentioned that when you're talking about traffic to inspect between the VPCs, we recommend deploying firewall in a centralized deployment model. And the way you do that, you start using constructs like Transit Gateway or AWS Cloud WAN. So it becomes very important to understand how the underlying routing is made available to stitch all these flows together. So before we take a look at the traffic flow, let's take a look at, so if you're doing it with a Transit Gateway construct, then what you end up doing is you end up creating inspection route table and a spoke route table. Your inspection VPC gets mapped to inspection route table in Transit Gateway. Your spoke VPCs get mapped to the spoke route table. They have the appropriate routes, and as a result, when traffic is routed to Transit Gateway, does a route table lookup, and traffic gets routed to the firewall and to the source and destination. So Cloud WAN, we just released a new feature earlier today, service insertion. It's basically allows you to steer same segment across the segment traffic through the network firewall, construct like network firewall. And basically, it introduces a couple of new constructs like network function groups, traffic actions, traffic mode. If you're interested to learn about this feature, definitely go attend NIS302, a breakout session that's happening tomorrow. There's a chalk talk I'm delivering tomorrow on the same topic. So if you're interested in learning more about this feature, come attend those sessions. But at the end of the day, again, it comes down to like you end up creating a spoke segment. So in Transit Gateway, you have route table. In Cloud WAN, you have segments, layer 3 VRF concepts. That's how you segment the traffic. So you end up creating a spoke segment. It's global in nature. You basically associate the VPCs with the spoke segment. You associate your inspection VPCs with the inspection network function group. And then using traffic actions and mode, those route tables get populated with appropriate entries. You don't need to do anything, and traffic gets routed accordingly. So with that in mind, this is what the traffic flow looks like, right? When a spoke VPC wants to talk to spoke VPC 2, traffic gets routed, like matches the route entry, default route to the Transit Gateway or Cloud WAN. From there, it goes to the inspection VPC, back to the construct, and it finds the destination into the spoke VPC. Now, this is good, but like imagine what happens if you have a source in AZ1 and destination in AZ2. So by default, this constructs, transit gateway and cloud WAN, both of them maintain AZ affinity. What it means is, like in this situation, you have a source in AZ1. So when a traffic arrives at this construct, they're like, okay, I need to maintain the AZ affinity by default. It's coming in from AZ1. So I'm going to send it to the firewall in AZ1, and then from there it goes to the destination. Now, when the return traffic originates and reaches the transit gateway, it's like they're like cloud WAN. They'll be like, okay, it is coming from AZ2, and I need to send it to the firewall in AZ2. And at this point, you've introduced asymmetric routing, and traffic gets dropped. So what we need to do is you need to enable an attribute called appliance mode, which is again an attribute of an attachment, be it transit gateway or cloud WAN, doesn't matter, same thing. And this makes it AZ independent. So for the life of the flow, it picks a firewall and it maintains that firewall for the inspection, and that's how you avoid the asymmetric routing. So that was for within the region. Across the region, same concept. At this point, you have two transit gateways. You again do the cross-region transit gateway peering, modify so your inspection VPCs are associated with inspection route tables, spoke VPCs with spoke route table. Appropriate routing has been taken care of as shown in this diagram. It's static in nature, so you need to add those route entries in your transit gateway route tables. Once that's done, traffic will get routed accordingly. Similarly, in case of cloud WAN, it's a global in nature. The constructs are global in nature, so the segment spans across the globe. Whatever regions you have added, it will automatically get span across those things. And you end up creating what happens, we talked about service insertion. So when you use the feature like network function group, traffic action like send via, dual hop and whatnot, it automatically populates the route table with the appropriate route entries. So as you can see, it's a single, when you go to the UI, you will see a single route table. You will have to pick an edge location because, yeah, it's a global in nature, but it still has a, under the hood, it's using transit gateway-like technology to spin up the thing. So you have a edge-based route tables, and that's how the traffic gets routed. And with that, so this is a double inspection use case where, you know, spoke wants to talk to VPC2 in region 1, goes to the construct, goes to the inspection VPC in its local region, back to the routing construct, to the inspection VPC in another region, and to the destination, and the reverse path follows the same route. Hybrid kind of is the same concept. That being said, today you can do it using transit gateway, similar concept applies, or you can use cloud WAN. Today, cloud WAN does not support native attachment to DX gateway. So what you need to do is you need to peer transit gateway with cloud WAN, and then you are able to connect your on-premises with the AWS cloud WAN and enable the connectivity. So this is how the traffic flow would look like. So that was all about lateral movement of the traffic, how you inspect the traffic using those firewalls within the lateral movements between the VPCs in the same region, across the region, and whatnot. The next one that comes up is ingress, so traffic coming in from internet to a resource in the cloud. I'm not going to talk too much about this topic because we just had a session, NIS304. It goes into detail into this topic. It's in fact a very interesting topic, ingress inspection architectures. So I would recommend taking a look at that session, NIS304, when it's up on YouTube. That being said, here in this situation, you have a web application firewall, which you can associate it with an application load balancer. You can also associate it with a CloudFront, and you can also have a network firewall that can sit between your application load balancer and the targets, or between the application load balancer or like load balancer and the internet gateway. And this is where it comes, it's important to like when to use web application firewall, right? So for it's recommended, like if you're inspecting layer 7 traffic, first route that traffic to web application firewall, let it do the inspection, let it do its block, allow, whatnot, and then route it to network firewall if you need to. But then there might be use cases where you want to inspect layer 4 traffic. You're running a layer 4 load balancer. That's where you start looking at inserting network firewall into the path. So network firewall placement plays an important role. You can place a firewall between, as I said, between the load balancer and the internet gateway. We call it gateway route table, aka ingress routing. Or you can insert the firewall between the load balancer and the targets. As you can see, the difference is like basically you will see the firewall will see the original IP in case of more specific routing and whatnot. And basically, you need to decide where you want to place it. You have to might use proxy protocol or export it for to get the original client IP and whatnot. The thing to keep in mind is when you are using VPC routing enhancements, more specific routing, and you are using network load balancer, today it does not support target group of type instance. You have to use target group of type IB. Then only you can insert the firewall between network load balancer and targets and its targets. And these are some of the considerations whether you want to distribute it or centralize it. It's a very interesting topic. Come find us if you want to learn more about it. But it's like these are some of the high-level consideration, right? You might have a requirement where you want to do a centralized DMZ and you want to basically, you have a requirement from your InfoSec that everything should come from a centralized DMZ. Or you have a blast radius requirement where you want to make sure that it's siloed and you want to make sure it's in its own bucket. Traffic volume and network cost comes handy because that's what does, it's like it's each of those constructs that I talked about, transit gateway, cloud WAN, they add what we call as data processing. So if you have a lot of volume of like traffic, big volume of traffic going through those things, then data processing can be something that you need to consider. On the other end, if you have large footprints, then the number of endpoints that can come into a play as well. And then operational simplicity. And also the scale, right? And that's what Scott is going to talk about in his use case study, because each and every construct has its own sort of scaling requirements, firewall endpoint, transit gateway endpoint, cloud WAN, ENIs and whatnot. They all have their own sort of scaling requirements. So you need to also keep that in mind that throughout the path, you're able to maintain the same sort of scaling requirements. So with that, I will hand it over to Scott. He's going to talk about egress, case study, and then conclude with observation and orchestration. Thank you.
Awesome. Thank you, Pratik. So I promised you all that we're going to talk about a customer use case where they're pushing 10 terabits per second through network firewall. Before we get to that, though, let's take a quick look at an architecture that relates to this particular use case. So when we talk about egress to the internet, we have a couple options. We can use a proxy, a NAT, something that's going to update that source IP address and go out through our internet gateway. When we go through that, we have several considerations of whether we use proxy versus NAT, whether we use our own managed NAT or AWS managed NAT, right? And with AWS managed NAT, you get that very scalable egress control. You get a point to filter on as well. With proxy, you get some layer 7 indications, but you have to manage that. And there's some ways to manage that we'll not go into here, but you can manage scaling and still do proxy. It just doesn't scale as well as going through NAT gateway and something like network firewall or a third-party firewall with gateway load balancer. So with AWS Network Firewall, we can place AWS Network Firewall between the EC2 instance and the internet gateway. We just route our default route from the private subnet to our firewall subnet, where the firewall is and the firewall endpoint, or the gateway load balancer endpoint, depending on what you're using. And then we route that out to the internet, and vice versa on the ingress routing on the internet gateway route table. We can route back to that firewall to keep that flow symmetry. We can also consider where we place that firewall. Just like Pratik was talking about, we can place that firewall between the NAT gateway and the internet gateway, like shown here. Or we can place it between our workload and the NAT gateway. In the latter, we use more specific routing. It gets a little bit more complicated in terms of the routing configuration. Not too much more, but a little bit more. But we also, in the latter, in that more specific routing scenario, we get the ability to see the original source IP address. And that can be really important for your firewall rules to determine whether you allow something out or not. If we do the former and we go through ingress routing and we just use those default routes to do things there, right? We don't get to see the source IP address anymore. The source IP address becomes the NAT gateway. This was really prominent when we first released Gateway Load Balancer and Network Firewall. But we released more specific routing afterwards, and more specific routing has become much more prominent because, again, you get to see that original source IP address, and that's a really valuable piece of information. We also have to consider our model when we deploy egress inspection, right? Again, we have that distributed and that centralized model, just like Pratik was just talking about. With the distributed model, you get the really nice ability to scale. And that's what we're going to talk about in our use case here in a minute. And each VPC has its own egress point, its own exit point to the internet, or to wherever, right? That could be direct connect, that could be any number of things. But in this case, we're talking about the internet. And that means that each VPC has its own firewall endpoint and is only subject to the scaling of that firewall endpoint. If there's a configuration error somewhere or some other type of fault in our deployment, then we only impact that single VPC. And so it's some really nice characteristics. The kind of downside to the distributed model is that you have less control maybe, or you have to do more automation and more building to do that control to make sure that when your developers are spinning up VPCs that you have that inspection in place, right? Versus centralized where you control all that centrally. You also end up with a higher hourly cost on those endpoints usually. And so that may play a factor. However, and here's the routing for a distributed model, apologies. When we go to our centralized model, we save that hourly cost. We increase the data transfer cost though, using transit gateway, right, or Cloud WAN. But we get that centralized control that can have some really nice attributes. This also creates a point that can throttle your traffic, right? If you're sending very large amounts of traffic, that all goes through one kind of point that has one limit in bandwidth, which is that firewall endpoint. We're still talking about hundreds of gigabits here. For most people, not a big deal. For some people, it is. So do keep that in mind when we talk about centralized versus distributed. And so the way that we route the centralized model, we just go from our VPC through our transit gateway or Cloud WAN using that default route. We go into our centralized egress VPC that's managed by our network or security team. And then we route out through there using NAT gateway, AWS Network Firewall, Gateway Load Balancer with third-party firewall, whatever you happen to be using. So Pratik talked a lot about defense in depth. And one of the things with defense in depth comes with DNS firewall. Route 53 Resolver DNS firewall allows you to filter what queries your EC2 instances are making to DNS. This can be a really crucial aspect to manage stopping unwanted egress traffic right at the DNS query. It can also stop some data exfiltration concerns around making queries that have things you really don't want in them, right? That go to name servers and go out through DNS, right? So there's a lot of really cool aspects of DNS firewall. What's also really cool is that we released Route 53 Resolver profiles earlier this year that allow you to centrally manage your rules as part of one profile, share them out through AWS Resource Access Manager to all of your accounts in your organization, and attach them to all your VPCs, along with private hosted zones, query log configurations, etc. So some really nice attributes there. But this is a better together use case, right? DNS firewall alone is only going to stop the DNS query. Network firewall is going to stop the actual traffic, right? And so using these two together gives you a real nice defense in depth strategy to stop those kind of attack vectors that you may have out there, right? And control your surface area. So now let's get to the fun part and talk about a use case. A use case of 10 terabits per second. And who am I talking about? I'm talking about us, AWS. We use AWS Network Firewall ourselves. We were able to migrate more than 250 billion daily connections. Yeah, that's billion with a B, daily connections, and over 10 terabits per second sustained traffic to AWS Network Firewall. We were able to move off of physical firewalls to these, from several hundred physical firewalls to that distributed model. And we'll talk about what that design pattern looks like here in a second. This allowed us to scale much faster, to get much better visibility in our network traffic, and to reduce outages, increasing availability. It's given us some really nice characteristics that we just couldn't get with a physical firewall. And it is by far the biggest lift and shift of firewall into the cloud that we've seen, us ourselves. Here's what our design pattern looks like. If you think this is familiar, it is. We just talked about it. It's that distributed egress pattern. We run a lot of services in Amazon VPC, whether those be internal services, external services, whatever they may be, but they run in Amazon VPC, no different than anything else. And they have to go out through an internet gateway to access some public endpoint. And so to control that access, we're doing this in a distributed. And by just doing this in a distributed model with thousands of instances of AWS Network Firewall across the globe, we were able to reach those billions of connections, hundreds of billions of connections a day, those tens of terabits a second a day, or at any given point, right? Sustained load there. And just keep scaling, right? We can continue to scale. We don't have any concerns about being able to scale out even further than that. So some really nice characteristics and some really nice proof that AWS Network Firewall and these design architectures really do scale. But it's great that the routing scales, right? It's great that the service itself scales to the bandwidth, but how do you manage it all? How do you view it all? How do you see it all, right? Let's take a look at orchestration and observability. And it starts with AWS Firewall Manager. AWS Firewall Manager is a really underpraised service. It's really great. I just don't see enough people using it on a day-to-day. And when they do, it just clicks like a light bulb where they're like, oh, this makes sense. Why didn't I not use this? It allows you to control all of your firewall configurations through your AWS organization. That could be hundreds of accounts. That could be thousands of accounts. That could be hundreds of VPCs, thousands of VPCs, tens of thousands of VPCs. It works together with AWS Config to audit and prove that you're implementing the security you intend to. And it works through Resource Access Manager so you can seamlessly share it, right? And you don't have to run this in your root account, right? That's always been the concern of a lot of these services is when you're running something across an organization, you don't want to be running things in your root account. You can delegate a firewall admin account, and that can be your lockdown to your security team or whoever's controlling this, right? Firewall Manager allows you to control several different services through AWS WAF rules, Shield Advanced configurations, VPC security group configurations, Network Access Control List, which is new this year. We just released that in April. Network Firewall rule groups, Route 53 Resolver DNS Firewall rule groups as well. And it allows you to push these data points all into AWS Security Hub so you can get a view of what your configuration is, what your compliance status is, etc. So we have our multiple VPCs here, and we go launch a security group configuration. right? Or a network firewall configuration here. And we can choose our model that we deploy in, and it will deploy that firewall for us. One thing to keep in mind when you deploy this is that when you deploy, whether it be centralized or distributed, it's not going to update the routes. We don't want to cause an outage on your behalf. We want you to take care of when you actually apply those routes and start shifting that traffic, and do that very deliberately. But we can get everything preset for you, staged, ready to go, so that all you got to do is flip those routes over like we've been talking about in these previous slides and architectures. And it works very seamlessly. When we talk about observability, the first thing that comes to mind is VPC flow logs. VPC flow logs are enabled per VPC or per ENI, and you can see metadata about the traffic traversing your VPC. These are things like IP headers, source port, destination port, the protocol, the on a protocol number. You can see TCP flags in there. You can also see some really other interesting things that you wouldn't see in a traditional network, like the Elastic Network Interface ID that the traffic came from or was destined to. You can see the VPC ID. You can even see with some of our latest fields where the traffic is going, right? Whether it's going through an internet gateway, whether it's headed to transit gateway, whether it's headed to direct connect, or a number of other different things. And so it gives you some really great enriched metadata that you can report on, you can query, you can visualize, whether it be with Amazon S3 that you go to and you use Athena and AWS Glue to report on this, or you can also use QuickSights to visualize it. You can also push it to CloudWatch logs and create dashboards, visualizations, and queries through CloudWatch logs. So a lot of great opportunities there from VPC flow logs. But we didn't stop at VPC when we looked at flow logs. Our customers kept asking us, we want to see our transit gateway. We want to visualize the traffic coming in and through our transit gateway because that's that lateral movement. And so you can also enable flow logs in your transit gateway now per attachment and see a lot of that same data. Push it to your same destinations. But sometimes the metadata is not quite enough. Sometimes we want to see the full packet. With VPC traffic mirroring, you can actually replicate each and every packet that goes to that ENI and target another Elastic Network Interface, although I don't recommend that because it doesn't scale very well, it's not very reliable. Instead, you can target something like a network load balancer or a gateway load balancer endpoint. The network load balancer is really nice because it allows you to scale elastically there and consume those mirrored packets. The gateway load balancer endpoint is also a really nice characteristic because you may already be running a firewall appliance that allows you to consume that VXLAN encapsulated traffic from traffic mirroring and report on it, do intrusion detection, other similar things. What about VPC Reachability Analyzer, and where does that fit into the picture? With VPC Reachability Analyzer, we're able to analyze the path from one end to another and why something is not working correctly or why it is working correctly. It allows us to troubleshoot various connectivity issues, but it's also a way to automate connectivity reporting. So when we start thinking about deployments, we should all be doing infrastructure as code, whether that be CloudFormation, Terraform, CDK. When you do those deployments, you can use VPC Reachability Analyzer to say, thing A should be able to talk to thing B and report on it and see that, yes, it is. Or no, it's not, and maybe I should roll back that deployment. It's a really great characteristic from that, but it also gives you some great security characteristics because you can see that something is reachable or something is not reachable that's supposed to be, right? We also have, this is still Network Access Analyzer. We also have Network Access Analyzer, which allows us to see the kind of a regex type thing, right? It's not actually regex, but it gives you the ability to say, I want to see these type of paths that exist, these type of networks that exist that can reach my resource. Whether it be the internet, right? Can this resource be reached via the internet? Can this resource be reached by direct connect? Can it be reached by transit gateway, by another VPC, etc.? And so when we're talking about provable security, this gives us the ability to take this report, go to auditors, go to our CISO, go to our security team and say, here, this is exactly what access there is to this resource, and prove it. And so as we look at observability, these two things are really great together from the access analyzer and reachability analyzer. We can see all different paths, all the different access, all the different segmentation, and everything that we're doing. With that, I do appreciate you all coming out to see our session. I do ask that you please hold your applause because we have some other sessions going on and we don't want to disturb those presenters. But if you have any questions for us, Pratik and I will be available at the back of the room. And you can also reach out to us on LinkedIn. Thank you.